Beyond the rocky planets of the inner solar system lies a mystical world, water ice covered, with a liquid ocean beneath. And that took the interest of so many scientists and explorers. This world is Europa, one of Jupiter's biggest moons, and soon, we will be sending a spacecraft to unlock its secrets. Welcome to our deep dive into the Europa Clipper mission from NASA, an epic journey of uncovering the mysteries of a distant moon that may be harboring life. Europa is one of 79 known moons of Jupiter and is just slightly smaller than Earth's moon. Arguably, the most exciting instrument on board is the ice-penetrating radar, REASON. That radar will scan through the ice to map the subsurface ocean, searching for any pockets of liquid water or clues about the ocean's connection with the surface. The thickness of the ice and water can help us draw conclusions on geological history and possible biosignatures of the moon. But why does Europa have such a promising place to search for life? It all comes down to the ocean. It's thought that Europa's ocean is in contact with its rocky mantle, just like the Earth's oceans are. On Earth, hydrothermal vents deep in the ocean provide warmth and nutrients for entire ecosystems where sunlight can't reach. But the really cool thing about it is what lies behind its frozen crust. A huge ocean, which scientists think may have more water than all Earth's oceans combined. The surface of Europa is iced over with cracks, ridges, and reddish-colored streaks. These features are indicative of geological activity under the ice, a surefire indication that a very exciting possibility could be real. Europa's subsurface ocean may be warm enough to support life. Gravitational pull from Jupiter keeps Europa warm. Its parent planet causes immense tidal flexing, producing heat within Europa's core that may let its ocean remain liquid despite the frigid conditions on the surface. But why is this moon so important to planetary scientists? It's because, if life exists elsewhere in our solar system, Europa might be one of the best places to find it. On Earth, life has been discovered in some of the most extreme environments imaginable, deep beneath the ocean at hydrothermal vents where sunlight never reaches and the only source of energy comes from chemical reactions. These ecosystems thrive completely in the absence of light, sustaining themselves on heat and nutrients welling up from the interior of the Earth. Also, such conditions might prevail in the ocean of Europa. On Europa, where Earth-like hydrothermal activities occur, it would have appropriate energy and chemicals to maintain life in these dark, icy regions. While the surface of Europa is thoroughly radiation-saturated in an uninhabitable manner, the ocean beneath the thick ice crust protects it, possibly being habitable. If hydrothermal vents exist on the ocean's floor, they could create an environment where life could be sustained. That is where NASA's Europa Clipper mission comes in, designed to answer one of the most profound questions of humanity. Are we alone in the universe? If hydrothermal vents are on the ocean's floor beneath Europa, that would create an environment capable of sustaining life. That's where NASA's Europa Clipper mission enters into the fray, designed to determine one of the most serious of questions humanity asks itself. Are we alone in the universe? Europa Clipper will make nearly 50 close passes of the moon during its mission, coming as close as 16 miles, 25 kilometers, from Europa's surface each time. That tactic keeps the spacecraft safely away from Jupiter's extreme radiation belts, which could fry the instruments. These frequent flybys will have Europa Clipper capture detailed data and imagery of both the surface and subsurface of Europa, enabling scientists to learn about the potential for life in that moon. Whereas the surface of Europa is literally just an ice shell, exactly how thick it may be and how the ocean interacts with that overlaying ice remains unknown at present. The Europa Clipper, using a technique called ice-penetrating radar, will map out the thickness of the ice and search for pockets of liquid water within the shell. This will tell the scientists if the ocean is really reaching the seafloor, the missing ingredient, so far, for possible hydrothermal activity and life. Europa Clipper has been specifically fitted out with radiation shielding to protect the spacecraft and its instruments. It also will avoid direct orbit over Europa, conducting close flybys but staying farther away from Jupiter's radiation. The reddish streaks and dark patches on Europa's surface indicate that the materials from the ocean beneath might be reaching the surface. The Clipper mission will probe that material for the signs of the chemistry of the ocean. It will search for organic molecules, salts, and other compounds critical to life. Europa's surface is constantly being reshaped. In general, The lack of impact craters would suggest a rather young ice shell, probably caused by forms of tectonic activity or cryovolcanism. The Europa Clipper will return high-resolution imagery over the surface to understand how better the geology of Europa works and how interior heat can make its way to the surface. Such geological activity can be indicative that Europa's ocean is dynamic and potentially habitable. Europa Clipper is fitted with some of the most ambitious scientific instruments that have ever flown to deep space for it to achieve those high-range goals. Let's try to look a little more closely at a few of these. An ice-penetrating radar system, one of the mission's most vital tools, apparently will be used in this project to map Europa's ice shell and search for subsurface lakes or pockets of water within the ice. This powerful camera will provide high-resolution imagery of Europa's surface, enabling scientists to study the Moon's geological features in unprecedented detail. Mass specs will analyze particles that are ejected from Europa's surface and atmosphere, helping identify organic molecules, salts, and other key compounds. The spectrometer shall study the spectral properties of the surface, determining the composition of materials such as salts, organic compounds, and frozen water. Linked together with a number of others on board, these advanced tools will allow Europa Clipper to obtain critical data on Europa's ocean, surface, and potential habitability. It is not a straightforward task to explore Europa. The Moon orbits within Jupiter's powerful radiation belts, and any visiting spacecraft are exposed to levels of radiation several thousand times higher than what we receive on Earth. The radiation is so strong that it could even damage the electronics and instruments on the Europa Clipper spacecraft. To protect those instruments, the spacecraft has been fitted with special shielding for its close flybys. Another challenge is simply the vast distance involved. With Europa nearly 484 million miles distant from Earth, it takes over a half hour for radio signals to travel in each direction. That very much dictates that Europa Clipper will have to be controlled autonomously, carrying out its scripted instructions of observations while sending raw data back to Earth for analysis. What, then, can be expected from the Europa Clipper mission? It is reasonable to speculate that the data returned may be truly groundbreaking in providing a new understanding of habitability away from Earth. Europa Clipper will not directly hunt for life. It will fill in critical details needed to understand whether Europa has the potential to harbor life or whether a future mission needs to focus on the ocean.